Hey there, future civil engineers! This is Mary Grace Aparo Ansero, and you're currently watching a video that talks about geotechnical engineering. At this video, you will know what is geotechnical engineering, its definition, and its history, the application of geotechnical engineering, the importance of geotechnical engineering, and geotechnical engineering as one of the specializations in civil engineering. So as the objectives of geotechnical engineering, its curriculum, and lastly we have the salary of geotechnical engineers. To formally introduce to you what is geotechnical engineering and its history, we have Ms. Gianna Borinaga.
Good day everyone. Good day sir and classmates. I am Gianna Borinaga. Today I will elaborate to you the definition of geotechnical engineering and its history. So geotechnical engineering, also known as geotechnics, it is the branch of civil engineering concerned with the engineering behavior of earth materials. It uses principles from soil mechanics and rock mechanics for solving its respective problems. As most civil construction projects are supported by ground, geotechnical interfaces with most of the sub-disciplines such as structural and environmental engineering. Geotechnical engineers have knowledge in geology and hydrology to provide solutions related to these sciences. Geotechnical engineering and engineering geologists perform geotechnical investigations to obtain information on the physical properties of soil and rock underlying and sometimes adjacent to a site. This knowledge is applied to the design of foundation, such as retaining walls, earth dams, clay liners, and geosynthetics for waste containment. Soil stand in geotechnical engineering as soil is described as an uncemented aggregate of mineral grains and decomposed organic matter with liquid and gas filling the space between solid and particles for the engineering application. Soil is utilized in a variety of civil engineering projects as a construction materials and to support structural foundations. Soil mechanics is a discipline of science that studies the physical properties of soil masses when subjected to various stresses. Soil and engineering are the application of the principles of soil mechanics to the practical problems. Geotechnical engineering is simply defined as the study of the foundation of the building. So we have the different fields under the geotechnical engineering. So the first one is geophysics. Geophysics is the study of the physics of the earth and its environment in space. It is the investigation of the solid and molten earth using physical principles which allows studies on large scales and the otherwise inaccessible deep earth. Geophysical methods are used to study large-scale earth structure, to measure the exact shape and size of the planet or geodesy, to study the dynamics of the earth interior and tectonic plates or geodynamics, to study the history of earth magnetic field and its present state or geomagnetism, mineral physics, and seismology. The second field under the geotechnical engineering is geology. Geology, it is the study of the earth, the materials of which it is made, the structure of those materials, and the process acting upon them. It includes the study of organisms that have inhabited our planet. An important part of the geology is the study of how earth, materials, structures, process, and organisms have changed over time. So the last field under the geotechnical engineering is hydrogeology. Hydrogeology is the study of groundwater, deals with how water gets into the ground, how it flows in the subsurface, and how groundwater interacts with the surrounding soil and rock. So the history of geotechnical engineering. Early 18th century, the understanding of geotechnical engineering as it is known today, the art of geotechnical engineering was only based on past experience through a succession of experimentation without any real scientific reasoning. Based on those experimentation, many structures were built, but some of those which crumpled and some are still standing. Recorded history tells that ancient civilization along the banks of rivers, such as the Nile River, the Tigris and Euphrates, the Wanghu, and the Indus. Beginning around 2700 BC, several pyramids were built as tombs for the country's pharaohs and their consort during the Old and Middle Kingdom periods, such as Pyramid at Giza. The construction of the pyramids posed formidable challenges regarding foundations, stability of slopes, and construction of underground chambers.
Application of geotechnical engineering. Geotechnical engineering involves the application of soil and rock mechanics as well as engineering geology to solve engineering problems such as design of foundations, slopes, excavations, dams, tunnels, and other civil, mining, and environmental engineering projects relating to the mechanical response of the ground. Here are some of the following specified applications of geotechnical engineering. First, transportation. Geotechnical engineers are responsible to ensure that roads, highways, and railroads are properly designed and maintained to ensure their longevity. The second one is deep foundation. All buildings, high-rise structures, bridges, towers, antennas, and essential infrastructure is carefully designed by a geotechnical engineer to transfer the loads of the ground. The third one is landslides. Geotechnical engineers are responsible to design excavations so that they remain stable as well as stabilize the natural slopes that may threaten public safety. The fourth one is underground structures, design and construction of tunnels, subways, and underground facilities. The fifth one is surface characterization. Geotechnical engineers perform a variety of tests on site or the laboratory to characterize the subsurface conditions. The sixth one is landfills. Geotechnical engineers are involved in the design of landfills to ensure that solid waste is isolated from the environment and that public health is protected. Ground improvement and soil stabilization. Use principle of physics and chemistry to modify the characteristics and properties of the subsurface. The next one is scar and erosion. Soils tend to erode when subjected to natural processes and especially in extreme weather that may involve rainfall, snowfall, tornadoes, hurricanes, and floods. The next one is contamination and site remediation. Are commonly engaged in cleanup or remediation of sites that have been contaminated and represent a help to the environment. The last one is structural design of buildings. Design, construction, and operate and maintain construction projects in various sectors, including roads and buildings for the public and private sectors. Geotechnical engineering can be applied to many different fields, including oil and gas, mining, including lithium mining and lithium extraction technology, construction, agriculture, water utilities, transportation, landfill, coastal restoration, dredging, and many more. Geotechnical engineering is one of the specialization of civil engineering. A subdiscipline of civil engineering, the discipline focuses on the use of scientific methods and engineering principles to interpret the characteristics of the ground to determine suitability for building and construction. Geotechnical engineering interfaces with the most of other civil subdisciplines such as structural and environmental engineering. As you can see from the presented graphic organizer, geotechnical engineering plays a vital role to different fields of engineering. Along the line is structural engineering, where there is an involvement of geotechnical engineering, such as foundation engineering, soil and structure interaction. Next is we have transportation engineering. In terms of tunneling and road engineering, geotechnical engineering plays a crucial role in that leading to the success of different essential infrastructures. For construction engineering, geotechnical engineering aids in ground structures, excavation, soil improvement, and earthwork. Now for environmental engineering is geoenvironmental engineering. Moreover, in earthquake engineering, the involvement of geotechnical engineering are in terms of seismic geotechnics and ground motions. Next is hydraulic engineering. Earth dams, scouring, groundwater drainage, and marine geotechnics are of course works of geotechnical engineers. In mechanical engineering, geotechnical engineering involvement is in terms of rocks, soil, and mechanics. Lastly is geology. In this field, geotechnical engineering takes place in regards of geological engineering, geomaterials, and geohazards. To sum up everything that has been stated, this actively illustrates how helpful geotechnical engineering is and how it makes every project of other fields of engineering a successful one. Importance of geotechnical engineering. As a branch of civil engineering, it is great of importance to construction activities taking place on the surface or within the ground, as well as to mining, coastal, drilling, and other disciplines. The study of geological material properties on a construction site are important to allow design and construction of stable structures. Do not settle, deform, or crack, and do not fall down due to foundation failure.
So the objectives or aims of geotechnical engineering is first, to perform soil investigation and to develop methods for soil sampling. Second is to classify soil properties in the light of soil engineering product. Third, to apply the result in soil investigation and sampling so as to use soil as construction material economically. And lastly, earth dams, seepage of water, groundwater, stability of slope, and well hydraulics. So the curriculum of geotechnical engineering, undergraduate courses. So first, we have the principle of soil mechanics. So this talks about soil as a foundation for structure and as material of construction. Soil formation, classification, its physical and mechanical properties, soil compaction, earth pressures, consolidation, and shear strength. Second is design of foundations and earth structure. Site investigation including evaluation of soil properties for design, designs of footings and piles including stability and settlement calculations, designs of slopes and earth retaining structures. Third is the advanced geotechnical design, analysis and design of earth dams including seepage, piping, and slope. Fourth is the fundamentals of earthquake engineering, response of simple soil deposits and structures to ground motion, hazard analysis by deterministic and probabilistic methods, seismic design codes. Fifth is soil mechanics laboratory. So this includes soil classification, grain size distribution, outer birch limits, specific gravity, compaction, expansion index, consolidation, shear strength determination, design problems, and laboratory report writing. Lastly, engineering geomatics. So this includes geodetic models for the shape of the earth, elements and usage of topographic data and maps, basic and advanced GPS mapping, Google Earth, advanced laser-based LiDAR mapping, quantitative terrain analysis, and seafloor mapping. So, we also have curriculum of geotechnical engineering graduate course. First, we have advanced soil mechanics. It includes insight and laboratory methods for soil property evaluation. Second, we have advanced foundation engineering, bearing capacity and settlement of shallow foundations, including spread footings and mats, performance of drive-in, pile, and drilled shaft, foundations under vertical and lateral loading, and construction consideration. Third, we have soil dynamics, response of a sliding block on a plane to cyclic earthquake loads, application of theories of single degree of freedom or DOF system, multiple DOF system, and one-dimensional wave propagation. Fundamentals of cyclic soil behavior, stress, strain pore water, shear behavior, shear moduli and damping, cyclic settlement and concept of volumetric cyclic threshold shear strain, and introduction to the modeling of cyclic soil behavior. Fourth, we have earth retaining structures. So this includes basic concept of theory of earth pressures behind retaining structures with special application to design of retaining walls, bulkheads, sheet piles, and excavation bracing. Effect of flexibility, creeping soils, and construction techniques on the stability of bulkheads and sheet piles. And mechanical stabilization of soils such as with soil nail and geosynthetic. Lastly is advanced cyclic and monotonic soil behavior, relationships between stress, strain, pore water, pressure, and volume changing the range of very small and large strains. Concept of normalized static and cyclic soil behavior, cyclic degradation and liquefaction of saturated soils, cyclic settlement of partially saturated and dry soils, and concept of volumetric cyclic threshold shear strain. So, let's talk about the salary of geotechnical engineers. So, the average pay of a geotechnical engineer is 424,533 pesos a year and 204 pesos an hour in the Philippines. So, the average salary range for a geotechnical engineer is between 305,348 pesos to 529,258 pesos. So this compensation analysis is based on the salary survey data collected directly from the employers and anonymous employees in the Philippines.
This will be the end of our report. This is BSCE-1C Group 6 and we hope that we impart knowledge about geotechnical engineering.
Padayon! Padayon!
Padayon!
Padayon!
Padayon!
Padayon
Future Civil Engineers!